So we've been working on vectors here, and we've talked about how you can have a point in space, and you can have a vector that goes from the origin to that point. And then we also talked about how you can create a line that goes between two given points. So I'm just going to make up another point, 5, 3, 4. And if you think about how to get from the first point to the second point, what you're doing is you're increasing your x component by 3, decreasing the y component by 2, and increasing the z component by 5. And so then I took that direction vector, 3, negative 2, 5, which is just doing 5 minus 2, 3 minus 5, 4 minus negative 1. We're just doing y2 minus y1, x2 minus x1. And I put a slider of k, and you can see that when k is equal to 1, my vector touches the purple dot. When k is equal to 0, my vector touches the green dot. And if I let k just vary back and forth, that touches all the points that are along a line. And the equation of the line you can find by just going x minus 2 over the direction component equals y minus 5 over the direction component for y, and then z minus negative 1 over the direction component, which is 5. And you can see how the vector just traces out all the points along the line, and that's all great. I'm going to do the same thing now, but I'm going to create a vector equation that traces out all the points that are along a plane. So let's give a third point as a target point. Let's say that my plane goes through the point 1, 2, 3, very original point. When I wanted my vector to trace everything out on the line, I added one direction vector that connected point A to point B, my green point to my purple point. Now I'm going to add a direction vector that connects to point C. I could either use the direction vector that goes from A to C, or I could go from B to C. Let's just do A to C. I'm going to add on here another parameter. Instead of K, let's use T. And I'm going to add on another direction vector. This is going from green to blue. So my x value goes from 2 to 1. That means my x value goes down by 1. My y value goes from 5 to 2, so that's down by 3. And my z value goes up by 4. And I'm going to add a slider for t. All right, so now let's watch how this works. If I make k equal to 0, I'm moving 0 steps in this direction vector, which connects my green to my blue. And if I make t equal 1, I'm moving 1 step from green to blue, and you can see my vector is touching the blue dot. If I make t equal 0, and I make k equal 0, now I'm just at my original dot, green dot. If I make k equal 1, then now I'm touching the purple dot, and I already showed you that on the line. If I let k vary, and I keep t at 0, I'm going up and down that line. If I make t equal to any constant value, like for example 1, you can see that my vector is now moving parallel to the line. If I make k constant, but allow t to vary, you can see that it's moving along the line that connects the blue and the green dots. If I make k1, or any constant, it's moving parallel to the line that connects the blue and the green dots. If I allow both of them to vary at the same time, the vector traces out every possible point that is on the plane that connects those dots. So this right here is called the vector form of the equation of the plane. We have a point that's on the plane plus one parameter times one direction vector plus a different parameter times the other direction vector. Okay, this is not a unique equation. I could have used any of my 3 points instead of 2, 5, negative 1. I could have used any multiple of the direction vector AB any multiple of the direction vector AC. I could have even used the direction vector BC or any of its multiples. Okay? All right, so the question remains, how do I actually get Desmos to graph the whole plane instead of just seeing the tip of the vector tracing out all of these points and just assuming that that would be the shape of a plane? So there's two ways to do that. One way is to take the cross product of your two direction vectors and then shift it to go through any of the points that you want. The other way is to solve a system of equations and eliminate your two parameters, and what you have left over will be an equation with x's, y's, and z's. Okay, and those two should give you the same answer. So let's see if I'm able to do that. So our first direction vector, d1, is 3, -2, 5. And our second direction vector is, let's see, up here on the top, -1, -3, and 4. So if I do the cross product, d1 cross d2, I'm going to get, I always just look at my formula. I know some people memorize it, but just look at your formula. So A2 times B3 minus A3 times B2. A3 times B1 minus A1 times, that was a 4, I think. Yeah, A1 times B3. And then A1 times B2 minus A2 times B1. After all that work, I get 6 plus 15, -5 minus 12, and -6 minus 2. So unless I made a mistake, which is really possible, I get 21, -17, and -8. What we know is we know that the cross product gives a vector that's perpendicular, and we know that every vector in the plane is perpendicular to the normal vector. Perpendicular means if I do a dot product, I get 0. So I do 21x minus 17y minus 8z, and I get 0. All right, so you can see this plane in there, and what I need to do now is shift that plane. Looks like I made some mistake. Where did I make a mistake? Let's see. Right at the beginning. I should have done A2 times B3 in my cross product. Let's see if we can fix this. A2 times B3 minus A3 times B2. So that would actually be -8 plus 15, which is 7. So let's see if I fix that, if that gets us tilted in the right direction. 7, okay. Yeah, now that looks still not right. Okay. A2, B3, A3, B2. A3, B1, A1, B3, A1, B2. This should be a -3. So I made multiple mistakes. A1, B2, A2, B1. So that'd be -9. So this is -11. Okay. Now that looks better. You can see that my plane now is parallel to those 3 dots. All I need to do is shift my plane so that it goes through any one of the dots. I'm just going to use the blue dot of x is 1, y is 2, and z is 3. And now my plane goes through my 3 dots. And if I turn on my points, you can see that the tip of my vector is tracing out the set of points that are in the plane. Okay, so that's one way to do it. I'll do the other way in a different video because I'm out of time. All right, let me know if you have any questions. Thanks for watching.